Hi, and welcome to the 10 square meter workshop. This is part 2 of my experience fitting a brushless spindle to my CNC machine. Part 1 covered the physical installation. Here I will cover the automatic control aspects, coming up after this. There are two parts to full control, the on-off switching and the speed control. The first is not radically different to power switching a router, except you are simulating a button press rather than controlling the mains power to the router. See my previous video listed below for details on this. The VFD will have a terminal which, when connected to ground, will cause the motor to run. This is easiest to arrange with the same type of relay as that used for the router, with the contacts connecting a run or forward terminal to the ground terminal. The one additional step is to delay the job execution until the spindle is up to speed. This is achieved by adding a dwell command after the start command. There is usually a post-processor that modifies the G-code generated by the CAD system to tailor it for your make of machine. This can normally be edited to add features. I use Vectric software and have generated a workbee.pp file for the post-processor. Here you see the command to output to fan 1 when the spindle start command is sent, and here is the command that causes a delay, in this case for 30 seconds. Another at the end of the file to turn it off again. Now for speed control. The G-code command for this is M3S, then the speed, for which your CAD system should generate. Vectric pick up the speed from the tool database and add it to the file. The post-processor that I modified had the elements in the opposite order, S followed by M3, which my Workbee does not recognize. I altered the spindle on content to ensure it was in the right order. At the machine end, one has to turn this command into an output that can be used to set the speed. I used the heater output E0 on the Duet controller my Workbee uses. The user should add commands by modifying the custom config.g file, which is modified as follows. The second last line disconnects this output from the heater control system, making it available. The last line declares that this is a CNC machine and should output the speed value on this pin at 1000 Hz, more on this later, with 24,000 RPM as the max speed. We will now get a speed signal on E0. But what sort of signal? It will be pulse width modulation, where a 24 volt output will be switched on and off 1000 times per second, with the on and off times varying to give the value. Not on at all for 24,000 RPM to always on for 0. How do we turn this into a voltage to feed the VFD? That requires a piece of electronics. A single dual op-amp can perform this task. Here is the circuit that I used. The first stage inverts the signal and level shifts it down from 24 volts. The resistor capacitor in the middle integrates it into a DC level representing the signal, and the second buffers the output and gives fine control to set the speed. The 12 volt regulator is not strictly necessary, but I wanted to make sure that a fault could not cause the VFD 12 volt input to be exceeded. I built this circuit along with the relay for on-off onto a small piece of Vera board and mounted it into a small box next to the VFD. There are 4 connections to the CNC machine and 3 to the VFD. This system has proven to be quite successful, giving speeds within 1% of the value. Good enough for this purpose. Because the op-amp cannot go down to 0 without a negative supply, it gets inaccurate at the bottom end, with a minimum speed of about 2500 RPM. But I've never wanted to have speeds that low, so this is not really a problem. I hope you found this video useful. Please subscribe if you want more. See you soon.